Hey everyone, welcome back to ITversity. In today's video, we'll be exploring some of the most common Python interview questions centered around collections. When I say collections, that means lists, dictionaries, sets, and even tuples. Also, we'll talk about everything in between. We'll tackle 15 problems that frequently come up in Python developer and data engineer interviews. These will test your skills in manipulating data structures, counting frequencies, removing duplicates, grouping information, and more. Now let's talk about why it matters. Mastering these questions is crucial whether you are aiming for a Python developer role or a data engineer position, or you just wanted to improve your data manipulation skills. Each problem will help you understand fundamental operations in Python that you will use daily. Now, what to expect as part of this video? We'll start with simple tasks like reversing words in a sentence and then move on to more involved problems like sorting dictionaries by value or grouping lists of dictionaries by a key. I'll walk you through the logic behind each solution and show you sample code that you can practice on your own. So, if you are prepping for an interview or just brushing upon Python essentials, stick around. Let's dive right into our first question, reversing the order of words in a sentence. Alright, let's jump into the problems and their solutions. Let's start with reversing the order of words in a sentence. I'll be using a VS Code notebook for these demos. If you need help setting that up, there's a video link in the description. In this case, given a sentence like hello world, how are you? You can see hello world, how are you? The output should be you are how world hello. In this case, the words should be reversed in the sentence. First, let's define a variable by name sentence, then equal to, then we should be able to specify the sentence which we are interested in. It is nothing but hello world, how are you? Now let's run this. To reverse word by word, first you have to split the sentence. For that, you should be able to say words equal to sentence dot split. Split is a function that is available on top of string. It will use space as a delimiter by default. You don't even need to pass space, but if the delimiter is something else than space, then you have to specify that delimiter. Now let's run this. In case if you wanted to see the help of split, you can say help, then you can say sentence dot split. You can see the outcome here. If separator is not specified, space will be used. You can see here. When set to none, it will split on any white space character, including newline character, char written character, tab characters, and so forth. In this case, space will be used as a delimiter. It will return a list. The list will contain 5 strings. You should be able to preview by saying words and then by running it. You can see it have returned a list. The list contain 5 words. Now, when it comes to list, you should be able to access the elements using square brackets. You can pick specific element at a specific position, or you can even create sublist using the main list using square brackets. For example, if I say words, then 0, it will give me the first element. If I say 1, it will give me the second element, so on and so forth. If I wanted to get first 2 elements, I have to specify the index from where I wanted to start and then colon and then number of elements I wanted to get. In this case, 2. Now let me run this. You can see it have returned hello world. You can skip 0. Even if you skip 0, it will pick from the first one up to second element. You can see here. Now if you wanted to get 2 elements from second one, then you have to say 1. And then up to the point where you want to get, in this case 3, this will return 2 elements, world and how. You can see. Now, if you wanted to get last element, you can say words, then -1. You can see the last element. You can actually reverse the list by saying colon -1. It will actually reverse the list. Now, the list which is like this is reversed. Once it is reversed, we should be able to concatenate these things using a function called join. It will ensure all the elements in the list are reversed. The way join can be used is like this. You have to specify a string using which you wanted to join. Now I should be able to say dot join, then words, then colon -1. Now let me run this. You can see it is working as per the expectations. In case if you wanted to assign this to variable, you can say reversed underscore words equal to words colon -1. Now I should be able to specify reversed words here. Now let me run this. In case if you wanted to assign to a variable by name reversed sentence, you can assign like this, and then you should be able to review the outcome by running this. You can see the sentence is reversed. You are how world hello. The original one is hello world, how are you? This is how you should be able to reverse a string by using the split on top of a string, and then reversing by using list operations, and then again using join, which is a string based function. You can see join is used on a string. In this case, the string is space. If you say hyphen, the words will be joined using hyphen as delimiter. That being said, it is very important question. Make sure you understand all the key concepts that are included in this scenario. The question might not be directly like this. The question might be tweaked a little bit, or it might be combined with other type of scenarios. Hence, you have to be fairly comfortable about the functions that are being used and also the concepts, not just code for this specific scenario. Let me recap quick. In this case, we split the sentence into a list of words, reverse that list, then join the words back into a single string. Next, we'll look at counting word occurrences, another common Python interview question. Now let's move on to counting word occurrences in a string and returning them as a list of tuples. The first element in each tuple will be word and the second element will be count. Again, I'll be using the same VS Code notebook. If you are not sure about how to set it up, look at the description. There's a link for the video. You should be able to follow it, and then you should be able to set up VS Code, and then you can take care of these exercises. That being said, now suppose we have the text hello world, hello world, hello. Hello is repeated thrice and world is repeated twice. We want a result like hello 3 and world 2. You can see each of these elements in the list is of type tuple. Let me highlight here. This is first element, this is second element. Each of these elements are of type tuple. This is the original string for which we wanted to find the word occurrences or count of each word. Now when it comes to the code, let's make sure we copy this, then say text equal to, now text is of type string. Again, we have to split the text into words. We have already seen how to split a text into words if the space is the delimiter. It is pretty straightforward. We just have to say words equal to text dot split. Now words is of type list. If you want, you can review by saying words. You can see the words contain 5 elements. Here we have to create a dict first so that we can get the word as key and the count as value. For that purpose, I am saying counts equal to curly braces. Now counts is initialized as empty dict. We have to iterate through the list. For that we can say for word in words. Then as part of for loop, we can have if condition. We can say if word in counts. So if the word already exists in the counts, which is nothing but a dictionary, the value will be incremented by 1. This logic will take care of the scenario where the word is already added as key in the counts dictionary. Otherwise, if it doesn't exist, then it will create a new key value pair, which is nothing but counts of word equal to 1. That is how it will work. So in the first iteration, counts will have hello comma 1 or hello colon 1, hello is key and 1 is value. In the second iteration, the counts will contain hello and world with 1 each. Then in the third iteration, hello will have 2, world will have 1, so and so forth. In case if you wanted to print about what is going on, you can say print then counts. In each iteration, we are printing the counts here. Now let me run this. You can see here in the first iteration, before performing any of these operations, it have printed empty dict. Then in the second iteration, it have printed the current version of counts, which is nothing but hello 1, hello is key and 1 is value. In the second iteration, it have printed hello 1, world 1. In the third iteration, because hello is already existing in the counts, it have incremented existing 1 by 1. This logic is executed. Hence, hello is 2 and world is 1. In the next iteration, again, world is already existing. Hence, the value of world is incremented. That's why world have become 2. To avoid any confusion, let me make sure I add the print statement here. Now, let me run this. You can see the last iteration. Because I have ran second time, it have doubled the numbers. To ensure it works as per the expectations, let's reset the counts. It is reset to empty dict. Now, let me run this. You can see the outcome. The outcome is as per the expectations. Hello is repeated thrice and world is repeated twice. However, we wanted to get a list of tuples like this. As of now, this is of type dict. Counts is of type dict. You can say type, then counts. It is of type dict. You can just say counts dot items to return list of tuples. However, this is list type, not exactly the list. To ensure it is actually of type list, you can say list then of count dot items. Now it is actually a list. You can assign to a variable by saying words or word underscore counts equal to list of counts dot items. Now let's say word underscore counts. You can see the outcome as per the expectations. Here we split the string. This is where we split the string. Then we track the frequency of each word in a dictionary, then convert the dictionary into a list of tuples. This is where we track the frequency of the dictionary. Then this is where we have converted the dictionary into list of tuples. Now let's tackle removing duplicates from a list while preserving the original order. We are still in a VS Code notebook environment. If you need help setting that up, there is a video link in the description. When it comes to the actual problem statement, consider a list like this. You can see there are repetitions of different values. 3 is repeated thrice, 1 is repeated twice, then 5 is repeated twice, 2 is not repeated. When it comes to the outcome, we want the result to be like this. If you observe, the order is preserved. 3 came first, followed by 1, followed by 2, and followed by 5. Here we need to ensure the order is preserved. If the order need not be preserved, then we can use set function on top of it and we should be able to get all the unique values. However, as order needs to be preserved, we need to ensure we use loops and also we use required if conditions to take care of getting unique values by preserving the order. Now first, let's make sure we create a variable by name numbers, which is of type list. Now the numbers is created, it is of type list. If order is not criteria, then we can just say set numbers. We should be able to get the unique values. But if you see, the order is broken. Now, as we have to preserve the order, let's create a variable by name scene, which will be initialized as empty set. Also, we'll create another variable by name unique numbers, which is empty list. As we iterate through these elements, we look up into the set, and if it already exists, then we'll ignore, otherwise we'll append to unique numbers. That's why we need to have empty set as well as empty list. Now let's start iterating. Let me say for num in numbers. In case if the element is not in set, which is scene, then we have to add to scene, otherwise we don't need to. Only when element is not in scene, we have to append to unique numbers. That's why we have this if condition. You can see the if condition here. Then scene dot add of num. Here, if the number is not in the set scene, we are adding it to the set. Add is the function which can be used to add to a set. When the number is first scene, we are also appending to list by name unique numbers. Append is the function that is available on top of list to add number at the end or to add element at the end. In this case, the element is of type number. Now let me run this. It is successfully run. We should be able to say unique numbers, and you can see the values in unique numbers. They are unique numbers by preserving the order. You can also see the outcome of scene. You see the order is not preserved. However, scene is being used to ensure we look up into it to see whether the number is already seen or not, or to track whether the number is already seen or not. This is how you should be able to come up with the logic to get the unique values by preserving the order from the original list. Here we iterate through the list. This is where we iterated through the list. Add each element to a scene set. This is where we are adding each element to a scene set. And if it isn't already there, we append it to unique numbers. This is where we are appending to unique numbers. This ensures duplicates are skipped, but the first occurrence of each element stays in order. Now let's get into the next scenario. Now in this scenario, let's merge two lists while removing any duplicates. We are still in a VS Code notebook. Once again, I'm reiterating, if you need help setting that up, there is a video link in the description. Also, if it is becoming too much for you to set up the environment, feel free to reach out to us. We'll be there to support you. You can always comment and our team will be there to support you so that you have smoother ride when it comes to handling these collection based scenarios. Now, suppose we have two lists. These are the two lists, list 1 and list 2. Here we wanted to create a new list. It should be combination of these two lists and also there should not be any duplicates. If you observe here, it have 3 elements and it have 4 elements, but 2 and 3 are repeated. When it comes to the final outcome, 2 and 3 present only once. And here order doesn't matter, hence we'll be using set operations to take care of this. That being said, there are multiple ways to solve this problem. But it is better to convert list 1 and list 2 to sets and then concatenate them. This is how the logic will look like. First, let me copy these and let me paste here. Now the lists are created. You can validate by saying list 1 and then list 2. You can always say list 1 plus list 2. It will concatenate both the lists, you can see, and then you can apply set. This is one way of solving the problem. You can see you got the set which you are looking for. You can then convert it to list again so that it is finally a list, because as per the problem statement, the result should be of type list. Now you can say list then set of list 1 plus list 2. This is one way of solving the problem. The other way is like this. You can say set of list 1, then pipe, then set of list 2. This is kind of union of both the sets. You can see it have created a new set where all the duplicates are eliminated. This is union operation. You should be able to perform union between two sets like this. Then you can convert this to list. Now you can run it and you can see the outcome. In this case, both the approaches gave you the desired result. However, the second one is better when it comes to the performance because it has to apply set functionality on smaller set of datasets. The performance will be better to eliminate duplicates in subsets and then concatenating them compared to performing set type operation on bigger datasets. However, both the approaches will give you the desired result. In this case, we use sets to handle duplicates automatically, but we can also use list operations as we have seen earlier. But even after concatenating the two lists, we have used set only to eliminate the duplicates. Then we turn the set back into a list. That way, we can actually get the final outcome as list. Now let's find elements that both sets have in common. Here we'll be having two sets, set 1 and set 2. When it comes to these two sets, we have 3 and 4 as common. You can see the final outcome should only contain 3 and 4. This is nothing but intersection operation on sets. It is very straightforward. Let me get into the solution. First, let me copy paste these two lines of code into the next cell. Then let me run this. Now set 1 and set 2 are of type sets. To get the common elements between the two sets, we just have to say set 1 ampersand set 2. Ampersand is used for intersection operation. Pipe is used for union operation. Now let me run this. You can see we got the common elements between the two sets. It is very straightforward. We simply use the ampersand operator to find items present in both sets. Ampersand is for intersection between two sets. So far we have seen 5 scenarios. Most of them are very simple. This is just to warm up about common operations that we perform on lists, sets, tuples, etc. Now it is time for us to get into more intermediate ones. If you like the content so far, feel free to hit the like button. If you have any feedback, please use comment section. Keep in mind, if you haven't subscribed to our channel yet, make sure to subscribe and stay tuned by hitting on bell icon. You will be notified whenever we publish content like this. We'll be creating a lot of content related to Python-based full stack development as well as data engineering in coming days. Next, let's flatten a list of lists into a single list. In this case, you can see there is a variable by name nested list. It is of type list. This list contains 3 elements. The first element is this one. Second element is this one. Then the third element is this one. All these 3 elements are of type lists. This have 2 elements. This have 3 elements. And then this have 1 element. Now we need to flatten all these 3 lists into single list like this. The outcome should be 1, 2, 3, 4, 5, 6. Let's see how to achieve this from this. That being said, first let me copy this. Let me actually copy this entire piece of code. Now let me paste here. Let me run this. Now nested list is created. It is of type list. I'll be creating a empty list by name flat list. Here we need to iterate through this nested list to flatten. First let me run this. Now it ran successfully. Now we should be able to say for sub, which means sublist in nested list. Now this for loop will iterate 3 times because this nested list have 3 elements. Each element is of type list. If you have a list and if you want to add a list to the existing list, you can use a function called as extend on top of list. Let me show you what I'm talking about and then I'll take it forward. In this case, I'm saying L1 equal to then 1 comma 2, L2 equal to 3. It have only one element. Now I can say L1 dot extend L2. Now if you look at L1 will be extended with the third element. The third element will be from L2. This will happen in memory. Now L1 is updated with these 3 elements. Originally there were only 2 elements. After extend, it contains 3 elements. So extend is the function that is available on top of list to add elements from another list. Now we should be able to use this function as part of this for loop to ensure we build a list which is flattened. Already we have flat underscore list which is empty list. Now we should be able to say flat underscore list dot extend sub. Sub will be list which is nothing but this one in the first iteration. Then in the second iteration it will contain this one. The third iteration it will contain this one. Extend will ensure these sublists or the subs which are from nested list are added to flat underscore list. In the first iteration, flat underscore list will contain 1 and 2. In the second iteration, flat underscore list will contain 1, 2, 3, 4, 5. In the third iteration, flat underscore list will contain 1, 2, 3, 4, 5, 6. You can actually print here. Now let me run this. It seems I haven't ran this or there might be typo. There is no typo, everything looks good, but still it didn't work. Let me run this once again. Now it ran successfully. Let me also make sure I run this. Now let me run this. Now you see in the first iteration, flat underscore list contain 1 comma 2. In the second iteration, flat underscore list contain 1, 2, 3, 4, 5. The combination of 2 lists. And in the third iteration, it contain the elements from all the 3 lists that are part of nested underscore list. We simply iterate over sublist and extend a single list. You can see here. This is what is iteration. This is where we are extending the flat list to build a single list with the elements from the lists from nested list. Now let's move on to next one where we'll be sorting a dictionary by value. Now let's sort a dictionary based on its values. Keep in mind a dictionary is nothing but a group of key value pairs. You can see here this dictionary contains 3 elements. This is the first element, this is the second element, and this is the third element. Each element is nothing but key value pair, and also keep in mind the keys are unique. You cannot have a dictionary with same key values related to multiple elements in the dict. It is very, very important for you to understand. When it comes to this problem statement, we need to sort this data in ascending order by values within this dict. So orange have 1, then apple have 2, and then banana have 5. We need to ensure the details are printed in the form of a list of tuples. You can see here. When it comes to the outcome, it is nothing but a list of tuples. This is list. Each element in the list is of type tuple. This is 1, this is 2, and then this is 3. Also, you can see that there are 2 elements in each of the tuples. The first elements are from keys of the dictionary. The second elements are from values of the dictionary. The outcome is sorted based on the values. We'll be using sorted function to ensure we sort the data based on values in ascending order from this dict, and we will end up getting a list of tuples. That being said, first let me define this variable. Let me copy. Let me paste here. Let me run. Now fruits is created. Fruits is of type dict. We can convert this dict into list of tuples. For that purpose, we have a function called as items, which is available on top of dict. We can say fruits.items, and if you run it, it return something called as dict underscore items. It is a list like object. You can see here this list like object have 3 elements. Each element is of type tuple. This is the first element and it is of type tuple. This is the second element which is also of type tuple. This is the third element which is also of type tuple. However, data is not sorted in ascending order by values. We need to ensure it is sorted. For that purpose, we can use a function called as sorted. If you look at help on sorted, it says return a new list containing all items from the iterable in ascending order. You can pass any iterable to sorted to sort the data. Even dict underscore items, which is of type list, is iterable. Hence, we should be able to apply sorted on top of it directly. Now, I should be able to say sorted. Then, when it comes to the variable, it is fruits, and here I can say fruits dot items. Now we have to specify the key based on which data is supposed to be sorted. If I just use sorted, it will sort the data based on keys, not on values. Let's see what happens. You see, it have just sorted based on the keys. Apple, banana, orange. However, we wanted to sort the data based on values. For that purpose, we can use a keyword argument called as key. Here we can specify the lambda function. I can say lambda and then x. X is of type tuple. We need to specify which element from the tuple should be used to sort. In this case, we wanted to sort based on the second element in the tuple. Hence, we can say x of 1. Now, let me run this. You can see data is sorted in ascending order. This is how you should be able to sort the data based on values from the dict. And when it comes to the outcome is already a list. Even though the input is not exactly a list, sorted always returns a list. You can see here. That's why it is saying return a new list containing all items from the iterable in ascending order. It took iterable as argument here, and along with that, we have even specified the key based on which data is supposed to be sorted. But when it comes to the outcome, it is nothing but list. Now, if you wanted to sort the data in reverse order, you just have to use one more keyword argument. And the keyword argument is nothing but reverse equal to true. Now data is sorted in descending order by values here. You can see 5, 2 and 1, which means data is sorted in descending order. But when it comes to our problem statement, we are supposed to sort the data in ascending order. Hence, we don't need to specify reverse equal to true. That being said, we use sorted with a key function pointing to the dictionary value, which is nothing but this one, to get the outcome as per the expectations of our problem statement. Now the next scenario is about computing total marks for each student. Here it is little bit advanced. We have to deal with dict where the values are of type list. You can see here. I'll walk you through the details in a moment and then I'll get into the solution. Here we have a dictionary where each key is a student ID and each value is a list of marks. You can see here, this is the student ID and here is the list of marks for this student. Same is the case with other two students as well. Here we are attempting to compute the total of these marks for each student. The outcome will be something like this. If you add these three values for 101, the sum of the marks is nothing but 253. Then for 102 it is 248. Then 103 it is 272. In this case, let's start with creating this dict. Now the dict by name student underscore marks is created. If you wanted to get marks of a specific student, you should be able to use this approach. This will give the marks of student 101. When it comes to 102, here are the marks. Now we need to sum up these things so that we get the results as per the expectations. As it is returning the list, we should be able to use sum like this to actually get the total marks for this student 102. Now we have to make sure it is implemented on all the items in the dict. The way you can implement is like this. First, you can actually create a empty dict by saying student underscore totals. Now the empty dict by name student underscore totals is created. Now we should be able to say for student ID comma marks in student underscore marks dot items. Keep in mind, student underscore marks dot items returns list of tuples. You can validate. As it returns a list of tuples, we should be able to use this approach to read corresponding elements in each tuple into two different variables. In this case, student ID will contain 101 for the first item, and then marks will contain the list for the first item. As it iterates through for the second item, this will be the student ID, and this will be the marks. Now you can actually say print, then the marks for student ID is marks. Let me say student underscore ID. First, let me run this. You can see the outcome. It is as per the expectation. However, we need to make sure the marks are summed up. The way you can sum up is like this. You can say student underscore totals of student ID. So in each iteration, we are adding a new element to this empty dict called as student underscore totals. And here we just have to say equal to sum of marks. So for each item in student underscore totals, the value will be total marks. Now let me run this. It is run successfully. You can say student underscore totals. You can see the dict with student ID and corresponding total marks. This is how you should be able to get the results you are looking for. In case if you wanted to sort the data in descending order by total marks, you can use sorted function. The way you can achieve it is like this. You can say sorted. Let me actually say student underscore totals sorted equal to student underscore totals dot items. This has to be passed to sorting or sorted. Sorted is the function which we can use. This is nothing but a list of tuples. The second element in the each tuple is nothing but total marks. Hence we can say key equal to lambda x of 1. I have already covered details about how to sort the data in the previous lecture or scenario. You should be able to review that in case if you wanted to have the clear explanation about this piece of code. Then here we wanted to get the data in descending order by total. We can say reverse equal to true. The scenario doesn't say that, but I wanted to explain how to sort this outcome so that in case if you are asked to sort the data based on the total marks that are computed, you should be able to do that without much challenges. Now let me refactor this so that it is readable. I have passed 3 arguments. The first argument is nothing but list type data here. The second argument is nothing but the lambda function based on which the data is supposed to be sorted. Then the third argument is nothing but reverse equal to true so that the data is sorted in descending order. Now let me run this. It has ran successfully. Let's validate to see if the data is sorted in descending order or not. You can see data is sorted in descending order. So the student with ID 103 got higher number of marks. This is how you should be able to get the results based on the problem statement by using the relevant approach. That being said, here to compute total marks for each student, we simply iterate through student ID and the list of marks. This is where we have iterated through student ID and list of marks. Then we have used sum on each marks to get the total marks. The total marks are assigned to a specific ID in this new dict that is being constructed as we iterate through the data. Now let's get into the next scenario. As part of the next scenario, let's find the most frequent element in a list. Here, if you observe this list, 2 is the most occurring element. It is occurring 3 times. 1, 2, and 3. Now, let's get into the details about which elements occurs most frequently and how often. In this case, first let me copy this and paste here, then run it. Now numbers is created, numbers is of type list. Now if you want, you can use the for loop and get the results as per the expectations. You can create a dict where the keys will be the numbers that are there in the list. The values can be number of times each element is repeating. You can just use simple for loop to take care of it. The way you can do it is like this. Here you can say counts, then equal to empty dict, then for I in numbers, if I in counts, then counts of I equal to counts of I plus 1, else counts of I equal to 1. This will give us the result we are looking for. You can see it have given a dict with all the elements in the list as keys and then corresponding counts as values. You can see that there are 4 distinct elements in numbers. They are nothing but 2, 3, then 5 and 4. 2 is repeating thrice, then 3 is repeating twice, 5 and 4 are displayed once. Same thing you got here. This is one way to get counts of each and every unique element in numbers. Also on top of it, there is a module called as collections within Python core library. From that module, we can import something called as counter and we can use that as well. In this case, I can say from collections import counter, then counts equal to counter of numbers. Now let me run it. Let's review the results. You can see the results as per the expectations. It have returned an object of type counter. It is similar to dict. You can see here. You can easily convert this to dict and then you can take it forward. Now we need to get the elements which are repeated most often. That is the actual problem statement, right? So in this case, we can say max underscore frequency equal to max of counts dot values. Counts is similar to dict type. We can use values to get all the values. Now we should be able to run it and then we can say max underscore frequency. It is nothing but 3. Now we can actually say most frequent equal to, here I am using list comprehensions. If you are not comfortable with list comprehensions, you can use conventional loops also. Now we can say num for num comma frequency in counts dot items if frequency double equal to max underscore frequency. Here max underscore frequency is nothing but 3. If the frequency of each and every element that is there in counts is 3, then only we are getting number along with the frequency. Now let's run this. Let's say most underscore frequent. You can see the outcome. It is saying 2. Only most frequent values are displayed here in the form of list. We wanted to see the actual number of occurrences also. For that purpose, we can say print most underscore frequent, then max underscore frequency. Now we should be able to get the results as per the expectations in our problem statement. Keep in mind here I am using list comprehensions. This is the main for loop. As part of the for loop, we have the if condition. Only if frequency is equal to max frequency, we are taking the number into the list. That's what it actually means. This shows element 2 appears the most exactly 3 times. You can see here. If there is a tie, most frequent will list all elements sharing the highest count. That's why we are using a list here rather than just having individual elements. Next, we'll look at grouping a list of dictionaries by a key. That will be the next scenario. In case if you are not comfortable with list comprehensions like this, you can also use regular for loops. If you want to use regular for loops, you should be able to come up with logic like this. Most frequent equal to empty list. Then you can say for num in counts dot items. If actually here I have to say for num comma frequency, because we have both number and frequency when it comes to each and every item that is going to be returned by this. You can actually see the results here, right? So this is the list of tuples. Here we are reading each tuple into 2 different variables. Now I can say if frequency equal to max frequency, then most frequent dot append num. Now I should be able to run this and then I can say most underscore frequent. This is the conventional for loop. This is list comprehensions. You should be fairly comfortable with both, but if you are not very comfortable with list comprehensions, you can use conventional for loops as well. Now let's get into the next scenario. In this scenario, let's group a list of dictionaries based on one of their keys. Suppose we have items like this. Items is of type list. If you look at this list, each element is of type dict. So this is nothing but list of dicts. Here each dict contains two attributes, name and category. For this dict, the name is nothing but apple, the category is fruit. Now when it comes to the outcome, we want outcome like this. Again, we have to get a dict. You can see this is nothing but a dict. This dict contains only two elements. The keys for those two elements are nothing but fruit and vegetables respectively, or fruit and vegetable respectively. When it comes to the value is nothing but list. You can see here, this list have two dicts. Both of them are related to fruit, and the names are nothing but apple and banana. When it comes to this list, there is only one dict. The name is carrot, and category is vegetable. So we have a list of dicts like this with three elements that we need to convert into a dict with two elements where the category is the key and the value is nothing but a list of elements related to that category, or list of items related to that category. This is a little bit complex scenario, but if you are comfortable with control flows, you should be able to develop this pretty fast. Now first, let's make sure we create a variable called as items. Items is of type list. You can see here it have three elements. Each element is of type dict. Now let me run this. Now let me say grouped, because the outcome is expected to be a dict with two elements. That's why we are initializing with empty dict. The name of the variable is nothing but grouped. Now we can say for item in items. So in each iteration we are processing each of these dicts separately. First let's say print of item. Let's print the outcome here. This is the first element, this is the second one, and then this is the third one. Now let us improvise on top of it. Here we can say cat equal to item of category. So in each iteration, I am assigning the category value to item. In the first iteration, cat will contain fruit. In the second iteration, cat will contain vegetable. In the third iteration, cat will again contain fruit. Now we have to say if cat not in grouped. Remember, grouped is empty dict in the first iteration. If the category is not in grouped, then we have to initialize the value for the corresponding category with empty list, because we wanted to come up with a list for each category like this. Hence, we have to say grouped of cat equal to empty list. Once we do this, whether we have category as the key in grouped or not, we should be able to say grouped of cat dot append of item. So here in the first iteration, it will create one element in the dict. Category will be the key, value will be the empty list. Then when it comes to this one, it is appending the actual element like this to the empty list. It will be the case with the first iteration. In the second iteration, we'll have two elements, one with fruit and second one with vegetable. Each of these elements will have lists with one element each. In the third iteration, the one with category fruit will have two elements in the list. In case if you wanted to display those results, you can also display. Let me run this, and then let me say print f iteration. I just wanted to print the iteration as well. Now I should be able to say grouped. In each iteration we are displaying what is happening with grouped. In case if you wanted to display the number, you can also use something called as enumerate. Then you have to say idx comma item. Enumerate will convert the list into list of tuple type object, and we should be able to read the index generated by enumerate into this first variable and the actual item into this second variable. Now we should be able to say iteration, then idx plus 1, because index starts with 0, hence I am saying idx plus 1. Now let me run this. You can see the outcome. This is the first element that is processed in the first iteration. The outcome is nothing but this one. There is only one element in grouped. The key is nothing but fruit. The value is nothing but list with one element. In the second iteration, the grouped have two elements. You can see here, when it comes to these two elements, the keys are nothing but fruit and vegetable respectively. The values contain each list contain only one element. In the third iteration, again, grouped have two keys, fruit and vegetable. Let me show the vegetable here. This is vegetable. However, when it comes to the actual elements in the value related to fruit, we have two. One is apple, the second one is banana. You can also display the details about grouped here. You can see the outcome. The dict grouped contain two elements. This is the first one and this is the second one. The first one's value is nothing but this one. It is list. The list contain two dictionary type objects. Here we loop through each item. This is where we loop through each item, check its category. This is where we are checking about its category and add it to the corresponding list in the grouped dictionary. Now let's get into the next scenario. So far we have gone through 10 different scenarios around Python collections. These are very, very important for coding tests with respect to interviews, be it entry level or even senior level positions around Python developers or data engineers. It is very, very important for you to be very comfortable with Python collections. In case if you are enjoying all the scenarios so far and if you are excited to see other scenarios, don't forget to click on like button. Also, if you have any suggestions or feedback, please use comment section. That being said, if you haven't subscribed to our channel yet, make sure to subscribe and also hit on bell icon so that you are notified whenever we publish content like this. We not only cover Python, we cover many other topics around data engineering, application development. That's why our channel is named as IT Versity. Now the next scenario is creating a dictionary from two parallel lists. In this case, you can see we have two variables, keys and values. Both of them are type of lists. Each list contains three elements and we wanted to club them together and come up with a dict like this. The elements from the first list should be keys. The elements from the second list should be values. This is a very simple scenario. If you are familiar about zip function, you should be able to use zip and then you can take it forward. In case if you wanted to use for loops, you can also use for loops. First, let me demonstrate using for loops. Then I'll actually walk you through using zip function. Now, let me copy this. Let me paste here. Both keys and values are created. Both of them are of type lists. Now we should be able to say d equal to empty dict. We wanted to create a dict, hence I am initializing d as empty dict. Now we should be able to say for I in range of len of keys. Len of keys is nothing but 3. Range of 3 will take us up to 2. It starts with 0, then 1 and 2. In the first iteration, I will be 0. In the second iteration, I will be 1. In the third iteration, I will be 2 because the keys contain 3 elements. Now we should be able to read the first element from the list by saying keys of 0. So in the first iteration, if I say keys of I, it will return x, right? Let's display that. Let me say print, then keys of I. You can see the outcome as per the expectations. However, we wanted to build a dict. For that purpose, we can say d of keys of I. In the similar manner, we should be able to read corresponding element from values. We can say values of I. Now, if I say d of keys of I equal to values of I, it will create an element in the dict in each iteration with the corresponding elements between keys and values as key and value. Now, let's run this and then let's say d. You can see the outcome as per the expectations. This is how you should be able to come with a solution using for loops. However, there is a function called as zip. Zip is part of core Python library only. You don't need to import anything. You just have to say zip keys comma values. As long as both keys and values have same number of elements and also as long as keys contain only unique values, it will work without any issues. Now let me run this. It have created zip type object. You can convert this to dict by saying dict of zip of keys comma values. Now let me run this and you can see the dict as per the expectations. It is very simple to use zip and create dict using two parallel lists. That being said, here we have used looping approach. Here we have used zip approach and we got the result as per the expectations. Dealing with a list of dicts is very common. Already we have seen a problem statement earlier where we have grouped the fruits and vegetables based on the category. Now in the similar lines, let's see another problem statement. In this case, we'll be grouping student records and computing totals. We'll go to the details and you'll understand what I'm talking about here. Let's assume we have a list of dictionaries where each dictionary represents a student's mark in a particular subject. You can see here the student records contain 6 elements. Each element is of type dict, and each dict or dictionary represents a student's mark in a particular subject. In this case, when it comes to student ID, the ID is nothing but 101, the subject is nothing but math, the marks in math is nothing but 80. So student with ID 101 have secured 80 marks in math. In the similar fashion, student with ID 101 have secured 75 marks in English, so and so forth. Using these student records, we wanted to group all records by their student ID and then compute the total marks for each student. The outcome should be something like this. For 101, the marks are nothing but 243. There are 3 elements in the dictionary for student ID 101. Then when it comes to 102, it is nothing but 172 because we have only 2 elements with respect to 102. With respect to 103, it is 95 and there is only 1 element for 103 in our student records. Now let's get into the solution so that we understand how to solve problems like this. First let me copy this, then let me paste here. Let me run this. Now student records is created. It is of type list. You should be able to say type, then student underscore records. You can see it is of type list. Let me pick one record. Let me say student underscore record equal to student underscore records of 0. I am picking the first element. The first element is of type dict. You can display it and you can understand that it is of type dict. From this first element, I should be able to get the student ID by saying student record of student ID. You can see it have returned student ID. Then if I say marks, it will give me the marks related to the student with ID 101 because the first record contain student ID as 101. The marks in that first record is nothing but 80. This is how we should be able to access values related to elements in the dict. Now to actually come up with the student totals, let me create a variable by name student underscore totals. It is of type empty dict. Now I should be able to say for record in student underscore records. So in each iteration, I'll be getting the dict. First, I wanted to capture the student ID. Let me say s underscore ID equal to record of student ID. Let's print the student ID of each and every element by saying print of s underscore ID. You can see the outcome here. I also wanted to print the marks. First, let me assign marks to marks equal to record of marks. Now let me say f, then s underscore ID marks. You can see the outcome here. We got student ID along with the marks just printed here. We haven't assigned to any type of data structure. Now let's come up with the logic to sum up these marks for each and every student ID. So here I have to say if s underscore ID not in student totals. So if the student totals which is initialized as empty dict doesn't contain the SID that is being processed, then we wanted to say student underscore totals, then s underscore ID equal to 0. In the first iteration, as SID 101 is not in the dict, it will be something like this. It will be 101, then 0. Now we wanted to actually add 80 to this one. The reason why we need to initialize this is if it doesn't exist, we need to first add element to the dict, then only we can manipulate that to actually come up with the total. Initializing with 0 makes a lot of sense here. Otherwise, you will not be able to come up with the solution. That being said, now I can say student underscore totals, then s underscore ID plus equal to marks. So here we are adding the actual marks to 0 in the first iteration. In the second iteration, as 101 already exists, it will not get into the if condition. The if condition will fail. By then, the student totals for 101 will contain 80. In the second iteration, 75 will be added to 80. Hence, it will be 155 after the second iteration. In the first iteration, this will be something like this, 101 colon 80. In the second iteration, it will be 101 colon 155. In the third iteration, as we get a new key, it will be 102 90. However, before getting into this, this will also be updated. In the third iteration, first it will become 101 colon 155, then 102 colon 0. Then it will actually become like this. In the third iteration, both these lines will be executed. This is how you should be able to get the total for each and every SID that is there as part of the student records. Now we should be able to run this. This will be misleading. Let me clean this up. Now if I say student underscore totals, you should be able to see the total for each student. You can see the outcome as per the expectations. That being said, here we have initialized an empty dictionary called student underscore totals. You can see here. Then we have iterate over each record in student records. This is where we are iterating each record in student records. Then if the student ID isn't in student totals, then we are setting it to 0 or we are initializing it to 0. Then we are adding or accumulating the marks to the student's total for each SID. And the final outcome is like this. In this case, sorting doesn't make sense because the marks for 101 is based on 3 subjects, the marks for 102 is based on 2 subjects, and marks for 103 is based on 1 subject. Hence, sorting doesn't make sense. Here, after running this piece of code, we have a dictionary showing all the totals for each student ID. This is how we should be able to solve the problems similar to what we got here. This is a very, very important one. Make sure you understand the process which I have followed and also all the key concepts that are covered in this. We are going through common coding questions related to Python collections for software developers as well as data engineers. Let's detour a little bit and talk about Python comprehensions. By the end of this, you will be quite familiar about Python comprehensions. Comprehensions are a powerful feature in Python that allow you to create and manipulate collections like lists and sets in a concise and readable way. We'll start with creating a list with random integers and then we'll take it further. We'll use the random module to create a list of 10 random integers between 1 and 50. The way you can achieve is like this. I can say import random. It will import random module from core Python library. Now I can say random underscore integers equal to square brackets. Here I am trying to come up with 10 random integers in a list using conventional for loops. Here I am initializing random integers as empty list. Now I should be able to say for underscore in range of 10, which means we'll be iterating 10 times. In each iteration, I'll say random underscore integers dot append of random dot randint from 1 to 50. This will always return a number between 1 to 50, that too integer number. That's why we are using randint. It is a function as part of random module. Now let's run this. It have ran successfully. You should be able to preview the results of random integers. You can see it have 10 numbers or 10 integers. These are the first 5 and then these are the last 5. Total we have 10. This is how you should be able to use conventional loops to generate 10 random integers. Now we can use comprehensions. If you are creating a list using comprehensions, then it is called as list comprehensions. The way you can come up with logic is like this. You can specify in square brackets. Then you can specify the for loop. When it comes to comprehensions, you have to specify the logic that is supposed to be executed in each iteration before for. In traditional loops, we typically make it part of for loop. We also need to break a line and indent like this. Here, in a single line, we should be able to say random dot randint of 1, 50. Then for underscore in range of 10, the reason why we are using underscore is we don't want to use the number that is being generated because of range. It is just a placeholder. Instead of saying I am saying underscore. Now let me run this. You can see it have created a list of 10 integers. This is how you should be able to create a list with random integers. As we have created a list with random integers using both conventional loops and list comprehensions. Now let's take care of computing the squares of each integer. So here I'll be assigning this to random integers. Let me say random integers equal to then list comprehension. Random integers will have 10 integers. I wanted to compute squares for each integer. In case if you wanted to use conventional loops, it will be something like this. You have to say squares equal to empty list. Then for I in random integers, squares dot append, then I star star 2. This is how we can compute a square in Python. We have to specify star 2 times. Now let's run this. Then let's say squares. You can see the outcome. For each and every integer, we are getting square of it. Instead of just getting a list of squares like this, let's say we wanted to get tuples. Each tuple should contain original number along with the square. Here you can specify in circular brackets and then you can say I comma I square. Now let's run this and let's run this. You can see the outcome as per the expectations. Now let's see how we can achieve this using list comprehensions. It is quite straightforward. We just have to say squares equal to, then for I in the actual variable, which is nothing but random integers. The logic should be specified before for loop. In case of comprehensions, here we are using list comprehensions again. Now let's run this and let's preview the output of squares. You can see the outcome as per the expectations. In case if you wanted to create a list of tuples, you just have to say I comma I square in a tuple before for loop. Now let's run this and then let's run this. You can see list of tuples as per the expectations. Here x square calculates the square of each number x in random integers, and then this logic actually take care of creates a new list containing the squared values along with the original values. Now let's come up with the sum of squares. Here the problem statement is nothing but sum of squares, right? In case if you wanted to use conventional for loop, it will be something like this. You have to say total underscore squares equal to 0. Then for I in random integers, total underscore squares plus equal to I square. Now let's run this and then let's preview the output. You can see the output here. It is nothing but sum of squares that are part of random underscore integers. Now if you wanted to use comprehensions, it will be something like this. You just have to say sum of, then for x in random integers, you have to specify the logic before for loop. Now you should be able to run this. You can see the outcome. It is not correct. Actually it is saying 3240. It is supposed to be 4424. The bug is instead of using x, I am using I. Now let me run this. You can see the outcome as per the expectations. Just to be in line with my for loop without comprehensions, I'll just use I rather than x. Now you can see the outcome. It is as per the expectations. So in this case, sum of I square for I in random integers creates a generator that computes each square on the fly and adds them together. Internally, it uses generator. Now let's go through the next problem statement. The next problem statement is nothing but getting a list of even integers. If you wanted to get a list of even integers using conventional loops, it will be something like this. You have to say evens equal to empty list, then for I in random integers. Here you have to specify if condition as well. You have to say if I mod 2 double equal to 0, then evens dot append. You have to append the integer which is even. Now let's run this and then let's check evens. You see we got only even numbers. The original random integers is nothing but this one. From this it have only picked even integers. Now you can actually use comprehensions with conditions as well. Let's get into the details so that you understand how to use comprehensions with conditions. So the logic will be something like this. You have to say evens equal to, because we wanted to create a list, we have to use list comprehensions. Hence we have to specify the square brackets. Here you can say x for x in random integers. You cannot specify the condition before for loop. If you have a condition that needs to be executed on each item in the list here or in iterable here, the way it will work is like this. The if condition should be after this iterable variable, in this case random underscore integers. So here I have to say if, then x mod 2 double equal to 0. Now let's run this and then let's check. You can see the outcome. It is as per the expectations. Now if you wanted to sum the even numbers, you can just have sum like this and then specify the logic. It will work as per the expectations. Here the x mod 2 double equal to 0 checks if a number is even. This is what actually checks if the number is even. The list comprehension, this is nothing but list comprehension. It includes only those numbers that satisfy the condition, resulting in a list of even integers. Finally, let's get into the details about unique even integers. So here, if there are duplicates, it will actually show those duplicates as well, but we wanted to see only unique even integers. Now let me say getting even integers here, this is the problem statement. However, when it comes to this list or random integers, it doesn't have duplicates with respect to any of the even integers. The way I'll be dealing with this is like this. So let me say random integers duplicates equal to random integers plus evens. Now let's run this and let's check. You can see the outcome. We have original random integers up to here, then the evens are repeated. We wanted to get only the unique even integers, not the ones with duplicates. We don't want to display the duplicate values. We just wanted to get these 5 numbers from this 15 element list. The way it will work is like this. You can say unique evens equal to, you can actually use set. This is nothing but set comprehensions. Here you have to come up with the logic. In case if you wanted to use conventional loops, first you have to initialize the empty set like this, and then you have to say for I in random integers duplicates, then unique events dot add of I. Here we also need to have the condition. We have to say if I mod 2 double equal to 0, then unique events dot add of I. Now let's run this. Okay, in this case unique events is initialized as dict, not as set. My bad. I have to say set so that it is initialized as unique set. Between set and dict we use curly braces, but dicts contain key value pairs, set contain only individual elements. The way you need to initialize the empty set is like this, not like this. This will not work. This will be initializing as empty dict. That being said, let's make sure you run this and also run this. Then let's review unique events. You can see it have only the unique even numbers. There are 6 of them: 4, 6, 8, 18, 28 and 30. Now in case if you wanted to use comprehensions for this, the logic will be like this. You just have to specify curly braces and then you have to specify something like this. For I in random integers duplicates, then I. After for loop, we have to specify the if condition. We have to say if I mod 2 double equal to 0. Now let me run this. You can see the outcome as per the expectations. In case if you wanted to convert this to list, you can use list like this. It will take care of converting this set to list. This is how you should be able to use set comprehensions to actually get unique elements from the original list. That being said, here this logic I for I in random integers duplicates if I mod 2 double equal to 0 is a set comprehension that collects only the even numbers, automatically removing duplicates because sets cannot contain duplicate elements. In case if you wanted to convert it to list, you can use list on top of it. It converts the set back into a list, giving the list of unique even integers. That being said, we have covered list comprehensions, we have covered set comprehensions, as well as we have covered generator expressions as part of mastering Python comprehensions. When it comes to list comprehensions, it will be something like this. This includes condition, expression for item in iterable if condition. If you wanted to use set comprehension, it will look like this. In case if you wanted to use generator expressions with the functions such as sum, it will be something like this. You can also have conditions even for generator expressions. So we have seen list comprehensions, set comprehensions, as well as generator expressions. All these come under Python comprehensions only. We can even perform comprehensions on top of tuples as well as dicts, but they are not very common. That being said, let's also understand why use comprehensions. The reasons why we use comprehensions are nothing but conciseness, performance, and readability. When it comes to conciseness, we will reduce multiple lines of code into a single readable line. For example, if I pick this, there are 4 lines. This is first line, then this is second line, then this is third line, then this is fourth line. From 4 lines, we just came up with single line logic like this. This is nothing but conciseness. Then another reason why we use comprehensions is nothing but performance. When it comes to comprehensions, they are often faster than using traditional loops because they are optimized in Python's internals. If you want, you can actually review the open source code of Python to see how the comprehensions are implemented. As it uses internals of Python, the performance is typically better than conventional loops which we end up writing. Then the third reason why we use comprehensions is nothing but readability. When it comes to comprehensions, it makes it clear that you are creating a new collection based on some transformation or filtering. That being said, comprehensions are an essential tool in Python that can make your code more efficient and easier to read. Today we have seen how to create lists of random integers, compute their squares, sum them up, filter even numbers, and extract unique even numbers, all using comprehensions. Practice these patterns to become more fluent in Python's powerful data manipulation capabilities. We have demonstrated using VS Code. In case if you need assistance setting up your VS Code notebook, don't forget to check the video link in the description. You can definitely go to the details about how to set up VS Code and then start exploring Python in detail. I hope you are enjoying the content so far. Happy coding. We'll catch up in the next scenario or next lecture. In the middle of this video where I am covering coding scenarios for the interviews related to Python developers and data engineers, I have covered mastering comprehensions. The reason why I have covered it is because understanding comprehensions is very, very important. If you come up with solutions using comprehensions wherever it is relevant, you will get some additional brownie points in interviews. That's why I thought of covering mastering Python comprehensions in the middle of coding exercises related to the interviews of Python developer or data engineer. If you like this detour, make sure you click on like button, and also it will be great if you can provide the feedback whether you like this idea of covering important concepts in the middle of longer videos which covers wider topic. Based on that, I will accommodate these kind of topics in future in long form courses or videos. Also, in case if you haven't subscribed to our channel yet, make sure to subscribe and also hit on notification icon so that you are notified whenever we upload content like this. As part of the next scenario, let's partition a list into 2 lists based on a certain condition. Here we have numbers. The numbers is a list of 10 integers. We wanted to divide into 2 lists. One is evens, the second one is odds. The evens should contain only the even integers. The odds should contain only the odd integers. Now let's make sure we create a list by name numbers. It contain all the 10 integers. Here let me say evens equal to empty list. Then odds equal to empty list. Here I am initializing 2 empty lists. Now I should be able to say for num in numbers, then if num mod 2 double equal to 0, then evens dot append of num else odds dot append of num. Now we should be able to review the details about events. You can see all the even integers. Same is the case with odds. You can see all the odd integers. In case if you just wanted to create a list with only evens, then you can use list comprehensions the way we have seen earlier. But as we have to apply and divide into even as well as odd, it is better to follow this approach, because with one iteration we should be able to achieve whatever we are looking for. Otherwise we have to go through two iterations. That being said, in case if you wanted to get only those numbers which are divisible by 3, again you can use list comprehensions. The logic will be something like this. I should be able to say empty list. In that I can actually say x or I for I in numbers if I mod 3 double equal to 0. In this case, it will only give us those integers in the list which are divisible by 3. For the original problem statement, when it comes to the solution, we simply check each element against a condition which is nothing but num mod 2 equal to 0, and we have placed it in the correct list. The evens went into evens, the odds went into odds. Now let's get into the next scenario. In this scenario, let's rotate a list by a given number of positions k. In this case, nums is a list with 5 elements, k is 2. Rotating to the right by 2 of 1, 2, 3, 4, 5 gives 4, 5, 1, 2, 3. If k is 1, then the outcome should be 5, 1, 2, 3, 4. If the k is 3, then outcome should be 3, 4, 5, 1, 2. Like that, we have to rotate based on k. Now, let's make sure we create this variable by name nums by copy pasting this. Now nums is a list with 5 elements. Then let's say k equal to 2. Now both nums and k are ready. First let us explore some of the common operations which we can perform using square brackets on top of lists. Then we'll actually get into the solution. Now to get the first element from nums, we can say num of 0. It will give us the first element. If I wanted to get first 3 elements, I should be able to say colon 3. It will give us the first 3 elements. If I wanted to get last element, then I have to say minus 1. It will give us the last element. If I wanted to get last but one element, I can say minus 2. Now if I have to get last 2 elements, I can say minus 2 colon. You can see minus 2 colon is giving last 2 elements. So we should be able to say minus k colon here to get last 2 elements. In the similar fashion, we should be able to get the first 3 elements by saying nums of colon 3. You can see it have returned the first 3 elements. Now if we concatenate these two, we'll get the elements rotated in the list by k, where k is 2. So in this case we can say rotated equal to nums of minus k colon, which will give us the last 2 elements, then plus, then nums of colon k plus 1. Here I am saying k plus 1 in brackets. Now let's run this. You can see the outcome as per the expectations. So first we got 4, 5 and then 1, 2, 3. This is one way to solve the problem. Another way is you can also say colon minus k. Minus k is nothing but minus 2, which means 5 minus 2, which means 3. Hence, when we say nums of colon minus k, which means 3, we'll get first 3 elements. You can also experiment here. Instead of saying colon 3, let's say minus k. You can see the outcome here. Minus k is minus 2. Internally, it is same as 5 minus 2, which is 3. Hence, it is same as colon 3. That's why we got 1, 2, 3. Now, even if we run this and then run this, you can see it is working as per the expectations. Remember, if you have to use positive number, then you have to say k plus 1. Otherwise, you can use minus k. Both yield the same result. That being said, what if k is greater than 5? Here, number of elements in nums is 5. What if k is greater than 5? It will not rotate anything. It will just keep the results as is. Let's see what happens by saying 6 here, which is greater than 5. Most likely it will error out. Let me run this. Let me run this. Let me run this. It's a minus 6 colon. It is not erroring out. It have returned all the elements. It haven't rotated anything. Let me also say this. It haven't returned anything. Now let me run this and let me run this. It have given the result without rotating the numbers. But if you wanted to normalize, what you can do is you can apply this logic by saying 6 mod, or after saying k equal to 6, you can say k equal to k mod len of nums, which means it will be 6 mod 5, which will return 1, so it will rotate by 1. Now let me run this. You can see nums of -1 have given 5. Now nums of column -1 have given 1, 2, 3, 4. Here it is nums of -1 column, hence it have given only 5. Now when we run this, both will be concatenated and the outcome will be 5, 1, 2, 3, 4. This is how you should be able to normalize to deal with k when it is greater than len of nums. Now it is time for us to go to the next scenario. As part of the next scenario, we will see how to find unique elements in a list that appear exactly once. Now let's find the elements that appear exactly once in a list. Even though this is very simple, it is also a very common scenario. We need to take this list. It contains multiple integers. We want 1 and 6 as a list because 1 and 6 each appear only once. So first let's make sure we create the list by name numbers. Then let's say from collections import counter. Then let's say counts equal to counter of numbers. It have run successfully. Let's check the counts. You can see 4 is repeated twice, 3 is repeated twice, 2 is repeated thrice, 1 and 6 are repeated once. It have returned a dict-like object. We should be able to process this dict-like object and get 1 and 6. For that, we should be able to use list comprehensions. So in this case, I can say unique underscore ones equal to then num for num in counts if counts of num equal to 1, double equal to 1. Now let me run this. Let me check unique ones here. You can see the outcome. It have returned 1, 6. So in this case, counts is of type dict. This is the dict which is being processed. It is also iterable. When we say from num in counts, in each iteration, it will only get keys. The keys are nothing but 4, 3, 2, 1 and 6 respectively. We are checking if counts of the key which is nothing but the value is equal to 1 or not. Only when it is the case, we are adding that to list. Again, we have used list comprehensions to get the results we are looking for. In case if you wanted to use loops to get the count of each number, you can come up with logic like this. So here first you need to make sure you initialize empty dict. Let me say counts equal to empty dict. Then we should be able to say for num in numbers, then counts of num equal to counts dot get num comma 0 plus 1. Now in the first iteration, it will actually check whether the number already exists. So the first number is 4. When we say counts dot get of 4, as it doesn't exist, it will return 0. That 0 will be added to 1, and then the first element in the dict will be added. So in this case, after the first iteration, it will be 4 colon 1. Then after the second iteration, again 3 doesn't exist in counts, hence when it comes to counts dot get of 3, it will return 0. 0 plus 1 is 1. Here it will be something like this. This is after the second iteration. When it comes to the third iteration, it will be something like this. Even 2 doesn't exist, hence it will be like this. When it comes to the fourth iteration, which is 3, as 3 exists, counts dot get of 3 will return 1. 1 plus 1 will be 2, and the counts dict will be something like this. 4, 1, 3, 2, 2, 1. So get is a function on top of dict. If the key exists, it will return the value. If the key doesn't exist, it will return the 0. So num will act as the key. Num is from our list, which is nothing but this one. So this is how we are avoiding if condition to add a number or an element to the dict if it doesn't exist. If it does exist, we are just incrementing without using any if condition. This is equivalent to this one. Let me copy this. Whether you use this approach or this approach, we'll get the same result. We can say if num in counts, then counts of num plus equal to 1, else counts of num equal to 0. This is a bit cleaner compared to this. Within 3 lines, we are able to get the logic we are looking for. Here we have to type 6 lines. Even this one will give us the same result. Let's also print the outcome. Here I am saying counts. You can see it have returned the results as per the expectations. Here we should be having 1, not 0. Even this one will give us the same result. Using these counts, we should be able to use this logic to get those numbers which are repeated only once. 1 and 6 are the ones which are repeated once. Here we first build a frequency dictionary. It can be built either by using counter from collections, or it can be built using loops. Once the counter frequency is built, then we gather only those elements with a count of 1. They are nothing but 1 and 6. That being said, now let's get into the next scenario. Now comes the last scenario, which is nothing but mix convey. Given a string, generate a list of strings where each string has exactly one character in uppercase while the rest remain in their original case. Commonly, each position in the string takes a turn being uppercase. Now, hello will be the input. The output will contain the list. As we have 5 characters in hello, there will be 5 elements in the list. The first element have h in uppercase and remaining characters in lowercase. Then in the next iteration, the second character is in uppercase, remaining in lowercase. In the third iteration, the third character is in uppercase, remaining in lowercase, so on and so forth. This is how a list should be once we process hello and generate mix convey. Now let's get into the solution. First, let me say word equal to hello. Then we have to create empty list. Let me name it as wave list. Here we have to iterate depending upon the number of characters. When it comes to hello, it has 5 characters. Hence, we have to say for I in range of len of word. Now, when it comes to the characters in the string, it can be alphabets or it can be numbers also. If we have numbers in the string, then we cannot capitalize. Hence, we need to check if a given character is alphabet or not. For that, we should be able to say if word of I dot is alpha is a function on top of string to confirm whether a given string contain only characters or it contain something else as well. You can validate by saying s equal to hello. Now if I say s dot is alpha, you see it have returned true, but if I have 1 here, then you see is alpha have returned false. Keep in mind, is alpha can be used over a string which contains only 1 character. In this case, in the first iteration, I will be 0. Word of 0 will return h. As h is alphabet, this will return true. That is how it works. Now, as part of this if condition, we can say wave underscore word. Then we have to come up with a logic to get characters up to I, which means 0. In the first iteration, we will not be getting anything. So let me specify word of colon I so that we can get characters up to I. Let me say word equal to hello here. Now word of 0 will return h, but when we say word of colon 0, it will not return anything, because in the first iteration I is 0, it will try to use 0 as the upper bound, and when you use upper bound 0, then it will not return anything. But if it is 1, it will return 1 character. If it is 2, it will return 2 characters, so on and so forth. So in the second iteration, this will return 1 character, which is h. In the second iteration, this will return 2 characters, which are nothing but h and e. Now, after getting the characters up to I, we need to say word of I which means the character that is being processed in each iteration. In the first iteration, it is nothing but H, and then we are saying upper. So H will become uppercase in the first iteration. However, this will return only one character up to now in the first iteration. We have to concatenate the remaining characters as well. The way you can concatenate remaining characters is like this. You can say odd, then I plus 1, colon. This will return ELLO. This will return H. H will be in uppercase. This will return nothing. In the first iteration, this will return nothing. In the second iteration, this will return H. Then this will return E. E will be converted to uppercase. Hence, this will return uppercase E. Then we are saying starting from next character after E, get remaining characters, which means this will return LLO in the second iteration. So the outcome will be H capital E LLO. Now we need to append this string in each iteration to a list. The list is already initialized. The list name is nothing but wave list. Hence we can say wave underscore list dot append. Let me paste here, then let me say append. Now let me run this. However, it is saying list.append takes exactly one argument. I missed to pass the argument. The argument is nothing but wave underscore word. Let me specify the argument here. Now let me run it. Now let me see the outcome of wave underscore list. You can see the strings here. They are in wave format. This is how you should be able to generate Mexican wave given a string. Keep in mind, Mexican wave is very popular in soccer matches and in any other major sport events. People form Mexican wave by raising their hands in a continuous sequence. You can Google around and see what Mexican wave actually mean. That being said, here is what is happening when it comes to this logic. First, we are iterating over each character in the string. Let me show you that. This is where we are iterating through each character in the string. Then we are checking if the character is alphabetic or not. This is what is taking care of checking whether the character is alphabetic or not. This will ensure spaces, numbers or symbols are skipped. Then we are creating a new string where the character at index I is uppercase. You can see here, this is what is actually converting a particular character at index I is uppercase, and this piece and this piece will ensure other characters are as is. Now towards the end, we are appending the newly created word in each iteration to the list so that we get the list of words in the form of Mexican wave. This is the last question or last scenario. This is one of the very common questions in advanced tech companies for high paying jobs. Questions like these can end up getting you job in high paying tech jobs. Hence, make sure you practice as many as possible in similar lines. That wraps up our demonstrations of these essential Python collection problems. We covered everything from reversing words in a sentence to creating a Mexican wave string transformation. Each of them are solved using VS Code Notebook. If you missed any setup details related to VS Code, check the video link in the description. Also reach out to us so that we provide required support for you to get started with these scenarios. Keep in mind, these scenarios are not catered to a specific organization. You can be prepared to give coding tests around Python collections for any organization. That's why we started with the very simple ones all the way till the complex ones such as Mexican wave. I have taught quite a lot of people around data engineering and also Python development. Based on the feedback of my students, I have come up with the list. Definitely by practicing all these questions, you will master Python collections. Your confidence to face these kind of questions in interviews will definitely be boosted. Hence, make sure you practice all the scenarios without missing. That being said, in case if you have any suggestions or feedback, feel free to post in comments. We'll pick those suggestions or feedback and take it to the next level. If you are curious about any other specific coding problems around Python, let us know. We will actually create videos explaining all the key concepts around those problems. Also, if you haven't subscribed to our channel yet, make sure to subscribe and also click on notification icon so that when we publish content like this, you will be notified. Also, don't forget to hit on like button in case if you like the content in this video.